Good afternoon. This is our report on the accidents in Toronto. The, the problem we want to address is which are the places with more accidents based on temporal and atemporal conditions. First, we delimited the area in which we wanted to focus the most. So, this video shows the total accidents per square kilometer each month from 2014 to 2020. And from this video, we can see that there are three main police divisions in which the accidents are focused the most. Division 14, 51, and 52. And also, we can see that accidents in general reduced when the pandemic started. Firstly, from these three divisions, we can see that the most accidents occur during normal conditions. The visibility is clear, the principal place to collide with was intersections, road conditions were dry, the principal impact type was against pedestrians, the principal vehicle was automobiles, the most frequent maneuver was going ahead, and the state and condition of pedestrians and drivers were normal. And also, we obtained that the number of accidents increases on Fridays and decreases on weekends. And about the hour, the number of accidents increases from 3 p.m. to 6 p.m. hours.
However, despite it appears that most accidents occur during normal conditions and they just look as accidents, it is due to normal conditions happening more often than the other conditions. So, if we focus on the total temporal conditions, we could obtain the percentage of accidents happening during those conditions. So, by scraping the weather conditions every hour from 2014 to 2020 of Toronto, we obtain 30 different weather conditions, from which the principal is mostly cloudy. Once we had this data, our focus was to predict the probability of a collision based on temporal variables such as the weather, the day of the week, and the hour, and a special variable, the police division. By using machine learning algorithms, we obtained a model which predicts the probability of an accident given the variables mentioned before, and it shows them on a map like this one. This video shows the probability of an accident every hour of the week given that it is raining in every police division of Toronto.
Now, the previous model analyzes dynamic condition, but there are also places that due to the permanent conditions are prone to have an accident near them, which increases the risk of pedestrians being hit while being around certain public places. So, we focused again on the divisions mentioned before. This heat map shows the density of accidents in this zone, and although we can see how accidents are more focused on some places than others, we enrich the data using the geotab datasets. Firstly, geotab has a dataset of hazardous zones, which are based on harsh braking incidents, accident level incidents, and traffic flow. Each one of these hazardous zones has two main variables, the severity score and the total accidents in that zone. These graphs show the distribution of these two variables. And to visualize them, we follow this percentile scale to show different levels of severity and the amount of accidents. So, in this map, we can see the zones with a higher severity score. And in this one, we can see the zones with a higher amount of accidents. As we mentioned before, most of the accidents occur in the intersections, so we also analyzed the geotab intersections dataset, in which we obtained a distribution of the percentage of cars that don't stop in the intersections. And using the percentile scale mentioned before, we obtained this map, which shows the in red intersection in which the car stopped the less.
Finally, using the road impediments dataset, it shows the score each point in the street has based on the average acceleration of the cars and the percentage of cars that follows this acceleration in order to score the impediments. We use the same percentile scale and obtain the following map, which shows in red the places with more impediments or more difficult to transit. Using all these variables, we wanted to classify all the public places in Toronto in order to find the ones which are more prone to have an accident. Due to pedestrians being the ones that are hit the most, all these public places in which they congregate represent a risk for them. So we calculated the following variables for each public place in Toronto in a 100-meter radius. Total collisions, fatalities, property damage collisions, fail to remain collisions, amount of hazardous zones, total collisions in those hazardous zones, mean severity score of those hazardous zones, total impediments, and mean impediment score. Percentage of cars not stopping at the nearest intersection. After that, we implemented machine learning algorithms to reduce the dimensionality of the places and cluster the places based on those dimensions. Hence, we obtained this map of the public places in which the ones in red are the ones more prone to collisions near them. And the names of those places in red are shown in this slide.
Finally, based on all the data, we have these conclusions. According to the temporal variables, we found out that based on the day of the week, accidents increase on Fridays and reduce on the weekends. Based on the hour, accidents increase from 15 hours to 18 hours and reduce at night. And the police divisions which have more accidents are the divisions 14, 51, and 52. Although, based on the statistics, it may appear that normal conditions cause more accidents, this is due to normal conditions happening more often. However, the probability of an accident is different given a certain weather condition. So, with our machine learning forecast method, we can predict the probability of a collision every hour and hence advise police to send a patrol at a given hour to a given division in order to make drivers more alert of their environment and being more conscious of their actions. Finally, with our analysis on the atemporal conditions, we obtain the places which are more prone to have an accident near them. So it is recommended to apply permanent solutions to these places, especially focus on the intersections and the pedestrians, such as increasing signaling in intersections in order for the pedestrians to cross the street. And we can scale the algorithm to all the parts of Toronto to find every public place in which the pedestrians have more danger to have an accident and apply the same solutions. Thanks for your attention.